This video is more continued look at eventually working towards solving quadratic equations with methods other than factoring. Some of this is going to be review because we did it earlier in the year. We're looking specifically at solving with square roots. Okay, so that's remembering that something like r squared equals s, in order to solve this, in order to undo a squared term, I would take the square root. And when I do that, I have to remember that both s squared and negative s squared would give me the r value. So when we take the square root to solve for r, we have to take into account both the positive and the negative. You may see it written like this. Plus or minus square root of s means the same thing. Okay? But in order to do that, we also need to look at different properties of square roots. And we've specifically done this one already, looking at simplifying a square root by pulling out perfect square factors. Okay, so we're going to, before we look at the second one, let's look at A, B, C, and D, because we've done stuff similar to this. So specifically A and B we've done before. Square root of 18 can be broken into the square root of 9 times the square root of 2. So that leaves me simplified as 3 times the square root of 2. This should hopefully be familiar. 80, I do know that it's 16 times 5. Now if you're not sure about that, you would just find the first, I would divide it by 4, and then you might have to do this process a second time. But if I find the biggest one that goes into it, in this case it's the square root of 16 times the square root of 5, which simplifies to 4 square root of 5. Okay, so slightly more complicated is where I already have them split apart, and neither of these, 6 or 21, have a perfect square factor. But if I use the rule that I can, if I have the square root of 6 times the square root of 21, because they're the same root, I can put the 6 and the 21 underneath the square root together. So that gives me the square root of 126. Now, I know that that is divisible by 9, so I get the square root of 19 times the square root of 14, which is 3 square root of 14 altogether. 14 cannot be simplified any farther because it doesn't have any perfect square factors. Okay, if I do the same thing for D, I get the square root of 150, which is divisible by 25, so I have the square root of 25 times the square root of 6, 6 being something that is not simplifiable, so I get 5 times the square root of 6. Alright, so then we get into division properties. So if I look up here at quotient properties, if I have the square root of an entire fraction, that's the same as taking the square root of the top divided by the square root of the bottom. So that's like the square root of 4 over the square root of 81, or 2 over 9. Now I don't have to say plus or minus in this case because I'm not physically solving for a variable by taking the square root. The square root is already there, so I only have to take into account the positive because that's what's written. Okay, if I do the second one, the square root of 9 is 3, and the square root of 64 is 8. Oh, that's yucky. That's a little better. Okay, let's keep going. Alright, so I've got 2 more. Square root of 17 divided by the square root of 4. Now the square root of 17 is not simplifiable. It does not have any perfect squares, so I'm going to leave it as the square root of 17, but the square root of 4 is 2. Okay, and last but not least, the square root of 3, and I'm going to simplify the square root of 27. So that's going to give me the square root of 3, which is not simplifiable. The square root of 27 is the square root of 9 times the square root of 3. The square root of 9 is 3 times the square root of 3. So I notice that these cancel, so that's going to leave me with 1 in the top and 3 in the bottom. Okay. So at this point now, what happens, if one like h, what if the square root didn't cancel? What do I do with it? Okay, mathematicians don't like having square roots of any kind in the denominator, so we do something called rationalizing the denominator. If it's just simply a square root in the bottom, we multiply by whatever that square root is to the top and the bottom. If we have something that has a plus or a minus sign with a square root in it, we're going to multiply by something called the conjugate, and that just means reverse the sign that I have. So we call these two things the conjugate. Okay, so I'm going to multiply by the conjugate. Let's start simple, and then we'll talk about how to multiply by the conjugate. Oops. All right. So simplifying here using our quotient rule, that's the same as saying the square root of 5 over the square root of 2, and neither of these are simplifiable. So to rationalize the denominator, I'm going to multiply both the top and bottom by the square root of 2. Okay, so that allows me to put these two under the same radical together, which gives me the square root of 10, 5 times 2. And square root of 2 times the square root of 2 is simply 2. I cannot divide the 10 and 2 because the 10 is underneath the square root. Square root of 10 is not simplifiable. Okay, it doesn't have any perfect squares, so I would be done here. If I move on to the next one, I would simplify that the square root of 9 over the square root of 8. Square root of 9 is 3, and square root of 8 can be broken up into the square root of 4 times the square root of 2. Okay, and then for our last, we've got so we have the 3 in the top still. Square root of 4 is 2, and square root of 2. So what I see, that this 2 is okay, but we don't want a square root of 2 in the bottom. So I'm going to multiply both the top and bottom by the square root of 2. So that gives me 3 times the square root of 2 in the top. I've got a 2 that just carries down, and then a square root of 2 times the square root of 2, which is 2. So that gives me 3 square root of 2 over 4 altogether. So at this point now, let's look at the ones that are a little bit more complicated, and that means multiplying by the conjugate. So in order to get square roots out of the bottom, I have a 5 plus square root of 2, so I'm going to multiply the top and bottom by 5 minus square root of 2. That is its conjugate. I ran out of room. 5 minus, sorry, that's really tiny. 5 minus the square root of 2. So if you remember, multiplying binomials like we were doing in class, I have a 2 by 2, so I'm going to put 5 plus square root of 2 and 5 minus square root of 2. So 5 times 5 gives me 25. 5 times the square root of 2 gives me 5 square root of 2. 5 times negative square root of 2 gives me negative 5 square root of 2. And negative square root of 2 times positive square root of 2 is going to give me negative 2. So what you'll notice is this middle term with the square roots goes away. So I'm just left with 25 minus 2. So I get in the bottom, 25 minus 2 is 23. And then I can carry the 2 through. So that's going to give me 10 minus 2 root 2. And I'm going to finish there because 10 is not divisible by 23 and neither is the minus 2, and they don't share any common factors. So now if I do the same thing again for the second one, this time it's 7 minus square root of 3, so its conjugate is going to be 7 plus square root of 3. Okay, and again, if I go off to the side here, 7 plus square root of 3, 7 minus square root of 3. So I get 49, 7 square root of 3, negative 7 square root of 3, and negative 3. What you'll see pattern-wise here, when I multiply by the conjugate, it eliminates that middle square root term so that I'm left with only whole numbers. So I get 49 minus 3 is 46. And then in the top, I've got negative 6 times negative 7, or positive 7, and negative 6 times square root of 3. So I get negative 42 minus 6 square root of 3. I notice that all three pieces, the negative 42, the negative 6, and the 46, are all divisible by 2. So if I divide by 2, I'm going to get negative 42 minus 3 square root of 3. Sorry, that's overlapping here, so let me divided by 23. Okay, so now that we have gone through some of our algebra properties for square roots, let's use square roots to solve quadratic equations. Now this looks like what we were doing in class, and before what we would have said is, all right, well, let's subtract the 41 over to both sides, okay, and then factor it from there. We could potentially do that, but if it's not factorable, then I would be stuck. When I'm missing that middle term, I can solve directly for the x squared so that I can get x squared by itself. So I'm going to, rather than try to factor it, I'm going to subtract 5 from both sides so that I have 3x squared equals 36, and then I'm going to divide both sides by 3. Okay, so if I had tried to factor this, I would have had not been able to, because if I look at this, when I try to solve this for x by taking the square root, I get a weird number. The square root of 12 is what we call an irrational number. It is not able to be written as a fraction. So we would not have been able to factor this one, and we would have thought that we couldn't solve it. So the first new method, if we can't factor and I'm missing the middle term, I can just go ahead and get the x squared by itself and then take the square root of both sides. So now, as I said in the very beginning of this video, when you physically take the square root of both sides to get x equals instead of x squared, I need to take into account the plus or minus. So I get x is equal to both positive and negative square root of 12, which simplifies, it's square root of 4 times square root of 3, so that's 2 square root of 3. So plus or minus 2 square root of 3 would be our solutions. Or roots or zeros or x-intercepts, however you want to talk about them. Alright, so if I do the same thing for the next one, I'm going to have x squared equals 28. If I take the square root of both sides, I get x is equal to plus or minus square root of 28. 28 is split up into square root of 4 times square root of 7, which is plus or minus 2 square root of 7. Alright, last but not least in this group, I have a little bit more algebra intensive manipulations to do here. So I see 1/3 times a quantity. So to get rid of the 1/3, I'm going to multiply both sides by the reciprocal, which is essentially multiplying by 3. So now I have x squared minus 4 is equal to 15 times 3 is 45. And then I can add 4 to both sides. So when I add 4 to both sides, I get x squared is equal to 49. Take the square root of both sides, and I get x is equal to plus or minus 7. So that means positive 7 and negative 7 both.